This recording is to help you with lesson 1.04, combinations of functions. Alright, let's start out with adding, subtracting, multiplying, and dividing functions. So when we're adding functions, we're just adding like terms. So here we have f of x plus g of x. So 1 over x plus 1 over x squared. We do need a common denominator, so we need to multiply that first fraction by x over x. That way we get the x squared in the denominator. Then we can add the numerator. Well, x times 1 is just x. We get x plus 1 there. And we have that x squared in the denominator. When we subtract, same thing, we need a common denominator before we can subtract. So we get x minus 1 in the numerator and x squared in the denominator. Multiplying. We don't need common denominators when we multiply. We just multiply the numerators together. So 1 times 1 is 1. And we multiply the denominators together. So x times x squared is x cubed. Remember, you add your exponents of 1 plus 2 to get 3. Now when we divide, I'm going to actually change this to a multiplication problem. So 1 over x times, and then you take the reciprocal of the other fraction. So x squared over 1. 1's are going to cancel, so we get x squared over x right here. And we can take an x away from the top and the bottom, because they share that in common. So we really get x over 1, which is just x. Notice that we do have a restriction, so what is the domain of f over g? We do have a restriction because we do have x in the denominator right here in this step, that x cannot equal 0, because we do not want 0 in the denominator of a fraction. So we do have to state that the domain is all real numbers except x cannot equal 0. Alright, let's do f of g and g of f and f of f. Alright, let's start with f of g. F of g just means we're going to plug g into f. So here's the g function. And anywhere we see an x in the f function, we're going to plug it in. And you can see the steps, they rewrote it multiple times here. Well, here's an x, so I'm going to plug x minus 1 in there. So I get x minus 1 squared, written just like that. Now let's do it the other way around. Let's take g to f, so I'm plugging f into g. It always goes, the second thing goes into the first. So we have g of x squared, so that means here's an x, so I'm going to plug in x squared. We get x squared minus 1. And I'm going to plug f into itself. So I'm going to have an x squared go into for the x, so I get x squared squared. You multiply your exponents here because there's no x in between them. So you do multiply those exponents and you get 4. So x to the 4th power. Alright, for my next one, find two functions f and g such that you can come up with f of g of x to equal this. And there are many ways you can do this. There's no right or wrong. Oh, I shouldn't say there's no wrong answer. But there's not one just correct answer. So for example, we can say that f of x is the cubed root of x. Okay. That means g of x would have to be everything underneath the square root, which is your x squared minus 4. That way, when I plug g into f, I get this final result here. Here are some other possibilities. We could say the cubed root of x minus 4, and the only thing that needs to change would be your x squared, so we make g of x the x squared. And then some other ones that you might not have thought about, because I don't think they're quite as obvious, would be something like these two. And there's many more, but I think that these two are probably the most common. Alright, let's look at the domain of f and g and then f of g. So the domain of f is the square root of x where x is greater than or equal to 0. And if we graph that, we do realize that because we get something like this. Okay, now the domain of g of x is all real numbers, because that's a parabola that shifted 1 unit upward. And then finally, f of g, if we were to follow this through, we plug x squared plus 1 in for x and get the square root of x squared plus 1. And when we graph it, we notice that we get like a v. So that would be all real numbers.